Hello guys and welcome to my 5th lesson on quadratics. Today we're looking at inequalities. An inequality is where we have an equation where we have a greater than sign or less than sign. And it can be greater than or equal to or less than or equal to. But we don't have an equal sign. However, we solve by factorising in the same method as what we would if we had an equal sign. But there's a general method for solving quadratic inequalities. And I'm going to go through this with you before we go through some examples. The first thing we do is we make the inequality equal to 0. Now, when I say equal to 0, what I mean is we get 0 on one side of the equation, just like when we're factorising any quadratic. The second thing we do is then we factorise that, then we solve the inequality without considering the inequality sign. So this is the point where we then pretend that what we have is equal to 0, and it's important we do that so that we can then draw out a sketch. We can then see from the sketch which parts of the graph support the inequality, and we can then use that to form an answer, an inequality. Okay? So we're going to look at the first example here, and the first example says find the values of x which satisfy minus x squared plus 2x plus 4 is greater than or equal to 1. Following these steps, the first thing we do is make this have 0 on one side. Now this plus 4 is going to become plus 3 because we're moving this positive 1 across to become a minus 1. 4 minus 1 is 3, and this is still greater than or equal to a value, but the value is now 0. Therefore we can solve this by factorising. So, to factorise this and make it equal to 0, okay, we pretend it's equal to so we can draw the sketch, we need to get this minus x squared across to become a positive. So if we make this a positive x squared, then all these values will become negative because they're both positive. Okay? So this x squared minus 2x minus 3, and we pretend it's equal to 0. This enables us to then solve by factorising. And in doing so, we get, hopefully you can see we're going to get x plus 1 and x minus 3. From here we make each bracket equal to 0. So if we make x plus 1 equals 0, then moving the 1 across we get x is minus 1. And making the x minus 3 equal to 0, we get x is 3. So there are two values of x. And we can then sketch this quadratic. We can pretend this might be the point 3 and this might be the point minus 1. And they're the 2 points where it's going to cross the x-axis. They're the two roots of the equation. Now we need to think about what this graph is going to look like. Well, in the original question we had a minus x squared. Now, if we have a negative coefficient of x squared, then we should know this is going to look like an n-shaped graph as opposed to a u-shaped curve. So, it's going to have a maximum point. We can say it might be this point here, for example. But now we can see what the graph will look like. We can start to answer the question. This is greater than or equal to 0, according to the original question. So we're looking for the parts of this graph that are greater than or equal to 0. In other words, greater than this x-axis. And the points greater than, and therefore above the x-axis, are these points here. Okay? The part that converges to a maximum point. Now we have to think about how we're going to write this as an inequality. So we have to think whether this is a point that's converging to a maximum or minimum point, in this case a maximum point, or whether it's a part of the graph diverging. Okay? Well, in this case it's actually converging. It's going to this point. The part we're looking at is a part that's together, and therefore we write the inequality together. Okay? We write it all as one inequality. So we're looking for the parts that are greater than this x value, which we calculated to be minus 1, greater than or equal to minus 1. Remember the question has a greater than or equal to sign. But we're looking for the parts that are less than or equal to this value of 3 here. It's got to be less than this but above this. So we're looking for the parts that are less than or equal to 3 but greater than or equal to minus 1. So that's how we write the inequality. And there's our answer. Okay, so let's move on to the second question. You can have a go at this yourself if you want. Pause the video, have a go, and I'll go through it straight afterwards. Okay guys, hopefully you've paused the video and had a go. The question says, find the values of x which satisfy 2x squared plus 2x minus 5 is greater than 3x minus 2. Once again, following these steps, we need to make this have 0 on one side. So we get 2x squared now, the positive 2x minus 3x, because this is positive, moving it across. 2 minus 3 is minus 1x. Minus 5, now this minus 2 moved across will become a positive 2. Minus 5 add 2 is minus 3. And this is going to be greater than, now we've got 0 on that side. So this now is a form that we can start to think about factorising. So we then pretend that this is equal to 0. Okay? And now we can factorise this. Okay? So factorising this, we're going to get that, okay? Because 2x multiplied by x will give us the 2x squared. 2x multiplied by 1 gives us 2x. And x multiplied by minus 3 gives us minus 3x. 2x minus 3x gives us minus 1x. Then the minus 3 multiplied by the positive 1 gives us the minus 3. So this works. And now we, once again, make each bracket equal to 0. 2x minus 3 is 0, then 2x must be 3. So x is 3 over 2, 1.5. Now with this bracket, x plus 1 is 0, so x is minus 1. So we get x is minus 1 and x is 3 over 2. We now sketch the quadratic graph. We have minus 1 and positive 1.5. And now we look back at the question. Well, this is now a positive coefficient of x squared, unlike this question here. So if it's positive, we're going to get a U-shaped curve. So it's going to look maybe something like this. And the bits we're interested in, according to the question, are the bits greater than 0. So we're looking once again at the parts above the x-axis. However, hopefully you notice a difference to the previous question. We're now looking at the parts of the graph that are diverging and not converging to the minimum point. So unlike this, the inequality we write is not going to be together like this one. We're going to write them separately. So what I mean by that is if we look at the graph, we're looking for the points that are going to be less than this value, which is minus 1. So x has to be less than minus 1. And notice it's not equal to, because we don't have an equal to sign in the inequality. It's just greater than. And then with this point, we're looking at the parts greater than 3 over 2. So we're looking for the parts, greater than 3 over 2. Okay? So it's got to be greater than 3 over 2 or less than minus 1. Okay, you can see it's going to be greater than this point and less than this point. They're the parts we're interested in. Greater than 0, which is the x-axis. So they're the answers to this question. And we could write and here, or we could write or, might be better. Okay, because that's how the exam writes it. So x is less than minus 1 or x is greater than 0. They're the parts of the graph that are going to be greater than the x-axis, which is what the question requires. And it's diverging, so we don't write this as 1. If it was converging, then we'd write this all as one inequality like we have here. But it's not. So here's the last example. You might want to have a go at this at home. However, you haven't seen an example like this before. And therefore, I think it will be best if we went through the first part of it, at least, together. The first part gives us something with k's in. It says kx squared plus k plus 3x plus 4 is equal to 0. And it has two distinct real roots. That's a very key point. Two distinct real roots or solutions, okay? Now, if you remember back to our previous lesson, we said that if a quadratic has two distinct real roots, then the discriminant of this will be greater than 0. And we're then told to show that k squared minus 10k plus 9 is greater than 0. and find the set of values for k that satisfy the inequality. So we're doing the same thing with this part as we have in the previous questions, but we have to prove something first. So let's use the discriminant, which if we remember back is b squared minus 4ac. And we can use that with this, okay? So our a value in this equation is the coefficient of x squared, which is k. Our b value is the coefficient, the number in front of the x, which is k plus 3. And our c value is just 4. So we can now think about substituting these values in. Well, b squared, k plus 3 squared, is going to give us a quadratic minus 4 multiplied by our a value, k, multiplied by our c value, 4. Okay? Well, k plus 3 multiplied by k plus 3 gives us k squared. Now, plus 3k plus 3k is plus 6k. And 3 multiplied by the 3 gives us 9. And now we're minusing from this 4 multiplied by k multiplied by 4. Well, 4 multiplied by 4 is 16, and 16 multiplied by k is 16k. Now we can simplify that. Well, that's going to give us k squared. Now, plus 6k minus 16k is minus 10k. Okay? We're going to get minus 10k. And this positive 9 will stay as positive 9. And it says in the question that this, which of course is just equal to this value of the discriminant, has two distinct real solutions. Okay? So this is going to be greater than 0. This here is going to be greater than 0 if it has two distinct real solutions. And now hopefully we can see that that is what the question gives us. We've therefore proved that this is equal to this. We've turned this into this form. So that in itself is probably 2 or 3 marks in an exam. Okay? And the next thing we do now is just simply factorise this like we had before. And it's already equal to 0 for us. So we can just factorise straight away. This time with k's instead of x's. But it doesn't make a difference. So this is going to factorise to give us k minus 1 and k minus 9. Minus 9 multiplied by minus 1, 2 negatives give us the positive 9. Minus 1 multiplied by k is minus 1k. Minus 9k gives us the minus 10k. So this works. Then we get the k squared from k multiplied by k. This equals 0. So once again, we solve. K minus 1 equals 0, so k is 1. And then secondly, k minus 9 is equal to 0. Okay? So k equals 9. So our two values of k are 1 and 9. Now let's sketch this diagram here. 1 might be there and 9 might be there. In this case, it's a positive coefficient of k. Okay? The coefficient is just positive 1. So the coefficient of x squared is 1. Therefore, it's going to be a U-shaped graph again. Okay? With a positive, it's a U-shaped graph. With a negative, it's an N-shaped graph. So it could look something like this, with once again a minimum point. And we're looking for where this is going to be greater than 0. Now I'll draw this more clearly so you can see that actually the points are going to be diverging. It's these points we're looking at. And once again, it's the points that are diverging. They're moving outwards rather than converging to the minimum point. So if we're looking for the parts greater than 0, these parts here, then again it's going to be an inequality with separate ways of setting it out, rather than writing it together like we did in the first example. So here we're going to get an inequality that looks like, well, firstly it's got to be less than this point, which is 1, so k has got to be less than 1, or, well, this point here it has to be greater than, as you can see it's moving that way, so it's got to be greater than this point, which is 9. So there are our answers. K is less than 1, or k is greater than 9. Okay, so you can see from here it's the points that are going outwards, so it's going to be written separately. So hopefully you've followed that lesson, okay? All we've done is make the inequality have 0 on one side, factorise it, solve it with considering that to be equal to 0, draw a sketch, and then we can see what parts of the graph support the inequality. If it's the parts of the graph diverging, okay, moving apart, we write the inequalities separately. If it's a part of the graph that's converging to a point, the together part, maybe a minimum point or a maximum point in this case, then we write the inequality together like this, with x in between. So that's lesson 5 on inequalities. It may take you a few more examples to grasp what's going on there, but hopefully you can understand what's going on, and if you don't completely understand exactly what we've done, then please put a comment below and I'll get back to you as quick as I can. The next lesson will hopefully be moving on to surds. I may do another lesson just summing up quadratics, okay? Just to review the whole set of quadratic topic lessons. So there we go, guys. If you haven't already, please subscribe to my channel, please like the video, and I'll see you in lesson 6.